Now let's have the basic integration rules. Letting c be an arbitrary constant, let's have rule number 1, the constant rule. So the constant rule states that the integral of k dx, or with respect to x, is equal to kx plus c, where k is a constant. For example, I have here, evaluate the integral of 2 with respect to x. So following our constant rule, we have our k here, the constant is 2x plus c. That's already our final answer. Another example, let's have the integral of 5 with respect to x. That would be 5x plus c. Don't forget, it's very important for you to always write plus c. That would indicate the family of antiderivatives for our constant. Next, let's have the power rule. So the power rule states that the integral of x raised to n with respect to x is equal to x raised to n plus 1 over n plus 1 plus c, where n should not be equal to -1. So let's have here an example. Let's have the integral of x raised to 8 with respect to x. So our n here is 8. So following our power rule, so we have x raised to 8 plus 1 over 8 plus 1 plus c. That would be equal to x raised to 9 over 9 plus c. And that's already our final answer. Let's have another example. Let's evaluate the integral of x raised to 2/5 with respect to x. So here, our n is a fraction. So we have x, raised to 2/5 plus 1 over 2/5 plus 1 plus c. So we will have x raised to 2/5 plus 1, that's just equal to 7/5. So let's have 7 over 5 over, still the same with our denominator, 2/5 plus 1 is 7/5. Since we are now dealing with complex fraction, let's rewrite them. That would be now equal to x raised to 7 over 5 times the reciprocal of our denominator, which is 5 over 7. Plus c. Simplify. Our final answer now would be 7th root of x raised to 5 over 7 plus c, and that's our final answer. Now let's have the properties of the definite integral. Let's have property 1. It states that the integral of k times f of x with respect to x is equal to k times the integral of f of x with respect to x. So let's have an example. Let's have evaluate the integral of 2x with respect to x. So we write that would be equal to, our constant here is 2, times the integral of f of x, dx. So now we have 2, the integral of x, that would be times x 1 plus 1 over 1 plus 1 plus c. So now we have 2 times x squared over 2 plus c. We can divide out 2, so our final answer now will be x squared plus c. Now let's go to property 2. So property 2 states that the integral of f of x plus g of x with respect to x is equal to the integral of f of x with respect to x plus the integral of g of x with respect to x. So let's have an example. Let's have the integral of 2x plus 2 with respect to x. So here our f of x is 2x and our g of x is 2. So rewriting, that would be following our property 1 for f of x. So we'll have 2 times the integral of x, with respect to x, plus the integral of 2 with respect to x. So here we have, that's 2 times x raised to 1 plus 1 over 1 plus 1 plus, the integral of 2 with respect to x is 2x, following our constant rule. Now plus c. So you have now 2 times x squared over 2 plus 2x plus c. We can divide out 2. So our final answer now would be x squared plus 2x plus c. Now rechecking, you can see here that if we try to differentiate x squared plus 2x plus c, then we'd really come up with 2x plus 2. So that's how basically anti-differentiation is the reverse process of differentiation. Now let's go to property 3. This states that the integral of f of x minus g of x with respect to x is equal to the integral of f of x with respect to x minus the integral of g of x with respect to x. Let's have an example. Let's have here the integral of 3x minus 2 with respect to x. So that would be equal now to, since our f of x is 3x, so that would be 3 times the integral of x with respect to x minus, the integral of 2 with respect to x. So that would be 3 times x raised to 1 plus 1 over 1 plus 1 minus the integral of 2 with respect to x, following our constant rule, is just 2x plus c. Add your exponents, so you have 3 times x squared plus 2 minus 2x plus c. Now you may write your final answer as 3x squared over 2 minus 2x plus c. Now let's go to rule number 3. So rule number 3, that's the integral of e raised to x. So the integral of e raised to x with respect to x is just equal to e raised to x plus c. So for example, let's have the integral of 5 e raised to x with respect to x is equal to, okay, following our property 1, so that would be 5 times the integral of e raised to x with respect to x, okay, with respect to x, so that would be equal now to 5. Okay, the integral of e raised to x is just equal to e raised to x, so times e raised to x plus c. Multiply, that would be 5e raised to x plus c, and that's our final answer. Another example, let's have the integral of 3e raised to x, okay, with respect to x. So same steps. So we have now 3 times the integral of e raised to x with respect to x. So 3 times the integral of e raised to x is just e raised to x plus c. So your final answer now will be 3e raised to x plus c. And now let's go to rule number 4. So rule number 4 states that the integral of x raised to negative 1 with respect to x is just equal to the integral of 1 over x with respect to x, and that is ln, the absolute value of x plus c, where x is not equal to 0. So let's have an example. Let's have the integral of 2x raised to negative 1 with respect to x. Following property 1, we can rewrite this as 2 times the integral of x raised to negative 1 with respect to x. So we can rewrite 2 times the integral of x raised to the negative 1 is just equal to 1 over x with respect to x. So that would be 2, the integral of 1 over x with respect to x is ln absolute value of x plus c. So that's times ln absolute value of x plus c. Okay, so multiply, we will have 2 ln absolute value of x plus c. And that's our final answer. Another example, we have, okay, the integral of 3 over x with respect to x. Okay, so that would be now rewrite, that is just equal to 3 times the integral of 1 over x, okay, with respect to x. So that would be 3, the integral of 1 over x with respect to x is just ln absolute value of x plus c. Multiply, we have 3 ln the absolute value of x plus c, and that's our final answer.